Have you ever stopped to wonder if a machine can actually believe something? I don't mean just crunching numbers, but truly holding a belief and reasoning about it. Well, we're about to dive into the fascinating and, surprisingly philosophical quest to teach AI how to think about what it knows.
I mean, really think about that question. It sounds like something you debate in a philosophy class, right? But for people building AI, this isn't just a thought experiment. It's a massive technical challenge. How do you actually program a machine to have a concept of its own knowledge?
So here's the fundamental hurdle. If we want an AI to be truly intelligent, to go beyond just being a sophisticated calculator, it has to have a way to represent what it thinks is true. It needs to be able to handle its own beliefs and do it logically.
And that's really the endgame here. We're not just trying to build a clever parrot that mimics intelligence. The goal is to build a system that has a coherent framework for its own beliefs, one that can update them, question them, and even defend them based on a consistent set of rules. Okay, so how on earth do you even start to build something like that? Well, you need a special kind of toolkit. You need a formal language designed for the very act of thinking about thinking.
The main tool for this job is something called modal logic. The easiest way to think about it is like an upgrade for standard logic. If A, then B. Modal logic adds new layers, like it's possible that A, or it's necessary that B. But the really crucial part for us is that it lets a system formally say Agent A knows P or Agent A believes P. It's basically a grammar for certainty itself.
And once you're in this world of modal logic, you'll find it splits into two main paths. On one side, you have epistemic logic, which is the logic of knowledge, stuff that is provably factually true. And on the other, you have doxastic logic, which is the logic of belief, things an agent simply holds to be true. It's the difference between I know the sun will rise tomorrow and I believe I left my keys on the counter. Now here's where it gets really clever. Instead of treating knowledge and belief as totally separate things, some of the most elegant systems link them. An AI is said to believe something if it knows that that thing is more plausible than it not being true. It's just a brilliant way to take a fuzzy philosophical concept and bake it into a clean, computable rule. So, great. Our AI can have beliefs. But the real world is messy. It's always changing. New information comes flooding in all the time. So how does an AI change its mind without its entire logical framework just shattering into a million contradictory pieces?
This whole problem is called belief revision. You need to design a system that can take in new facts, figure out how they mesh with what it already believes, and then adjust its worldview accordingly, all without creating a logical short circuit. It is a constant, incredibly delicate balancing act.
The first stab at this, the AGM model, was pretty basic. It just assumed that any new information is always true and must be accepted. But you can see the problem there, right? That's not how we work. A much smarter approach is something called credibility-limited revision. This gives the AI something amazing, the power to be skeptical, to actually say, no, I'm not accepting that, especially if it contradicts a really core belief.
So this creates a much more rational, cautious AI. When new data comes in, it doesn't just blindly swallow it. It runs a check. It asks itself, does this clash with something fundamental I know to be true? Does this source seem reliable? And only if the new information passes that test does it get woven into the AI's worldview.
Okay, so we've got a system that can reason and even update its beliefs. But hold on, because this is where we go right down the rabbit hole. What happens when this super logical system tries to reason about itself? Suddenly, we're not just tackling an AI problem anymore, we're smacking right into one of the oldest, deepest paradoxes in the history of logic. Because when a system of logic becomes powerful enough to talk about its own statements, when it can look in the mirror, it can create these dizzying, infinite loops. These loops don't just confuse the system, they threaten to bring the whole thing crashing down. This is the danger of self-reference.
Take a good look at this sentence. That's it, 5 little words. But what you're looking at is basically a logic bomb. Just let that sink in for a second.
This is the legendary liar paradox. Let's walk through it. If the sentence is true, then what it says that it's false must be correct, so it's false. But wait, if it's false, then it's lying, which means the sentence is actually true. It's an endless loop. For us, that's a fun brain teaser. For an AI built on pure consistency, this is a fatal error, the blue screen of death. So how do logicians and computer scientists get out of this mess? Well, there are two main escape routes. The first is to change the rules of the game. You could introduce a third truth value, something like undecided or paradoxical.
The other option, which is a famous solution from a logician named Tarski, is to build a kind of firewall. You create a strict hierarchy of languages where a sentence can only talk about sentences on a level below it. It can never, ever talk about itself. It's a neat way to prevent the loop from ever starting.
Okay, I know what you might be thinking. Modal logic, paradoxes, language hierarchies, this all seems pretty abstract, doesn't it? But trust me, this is not just an academic exercise. Solving these ancient philosophical puzzles is absolutely critical for the future of artificial intelligence.
First up, AI safety. We need to build systems that are robust, that don't just crash and burn the second they encounter contradictory data from the messy real world. Then there's strategy. This kind of logic is essential for modeling complex situations where you have to think about what the other guy's thinking about what you're thinking, like in economics or game theory. At the end of the day, it gives us the tools to understand any complex system with feedback loops.
And that brings us to one last really big thought. This whole journey to build a perfectly logical AI, it forces us to get really honest about the fuzzy, sometimes contradictory nature of our own thinking. But if we actually succeed, if we manage to teach a machine how to navigate these paradoxes with perfect, logical consistency, what could that clarity teach us about the messy contradictions we all live with every single day?